Last time we talked about biodiversity on a big scale in the biosphere, so looking at how each individual organism works together in an ecosystem. Now we're going to get a little more specific and talk about the benefits of having diversity within a specific population. So, quick review from the definition we had last time. Population is just the number of individuals in a particular species. So, the things that we're talking about today are really just looking at individual species. And within those, there's multiple variations. Think about humans. We're all the same species, but we have different hair colors, different eye colors, different skin colors, different heights, different body structures. So we have a lot of variation within our own species, and that's true for all species as well. If those variations are helpful for surviving the environment, then we call that an adaptation. Not every variation is an adaptation. Let's say, for instance, that you have dimples and your best friend doesn't. Dimples is probably not an adaptation because I can't imagine it helping you survive your environment more. So not every variation is an adaptation. It is an adaptation if it helps you for surviving your environment. So let's look at polar bears. They have several adaptations that help them to live in the polar environment. So they've got thick fur coats to help them keep warm. They have light colored fur so they can blend in with the snow. So are these still considered adaptations if we look at the polar bear living somewhere else? Like at the North Carolina Zoo. The poor guy. Don't get me wrong. I love going to the zoo. I love going to see the polar bear. It's probably my favorite thing there. But oh my gosh, he has to be so miserable living in North Carolina with a thick fur coat. So those are now variations that are not adaptations for that animal because it isn't helping in its current environment. So some other examples of adaptation, camouflage. So camouflage can be where a prey is hiding in order to avoid being eaten. It can be a predator that is camouflaged, so it has the ability to sneak up on its prey. But one way or the other, it's about blending in with your surroundings. Another really cool adaptation is mimicry. So mimicry is where you're looking at one organism and it looks very similar to one that's dangerous. So let's say that I'm a hawk and I am looking for something delicious to eat and I see this scarlet king snake. Well, I could eat that as a hawk, but it looks really similar to the eastern coral snake, which me and my hawk buddies know that's poisonous. So maybe that's a non-venomous snake, but it looks really similar to something I know I'm not supposed to eat, so I'm going to avoid that. So why is it helpful to have these variations and adaptations? Well, it can help individual organisms to live to see another day, but it can also help the population as a whole. Because we know that the environment is constantly changing, whether we're talking climate change, whether we're talking weather changes, or just actual changes to the planet as a whole. So if I have variation within a population, hopefully one of those variations is helpful for surviving that new environment. So the more variation in a population, the more likely it is for that species as a whole to survive. Because if they've got useful variations, then they're more likely to live to see another day. They're more likely to mate and then pass on those favorable traits to the next generation. So then that generation is a little more likely to survive, and then the next generation is a little more likely to survive. Now, organisms that don't have favorable traits are less likely to survive long enough to mate and pass on their less favorable traits to the next generation. So that, in a nutshell, is natural selection, where the favorable traits become more and more common, and the less favorable traits eventually disappear. So a good example of this is real simple, but there's these birds, and they love eating them some green beetles. So As time goes on, the green bug population is going to decrease, right? Because they're being eaten up left and right by these birds. The orangey brown population, on the other hand, though, not their favorite. Their population is going to be able to increase. It has nothing to do with green or brown being better than the other. It's just in this particular example, it is more beneficial to be brownish orange to survive your environment. So we're going to see their population increase while the other one decreases. So another example of this would be human population. We are currently experiencing exponential growth. That was something that we covered last time, where our population has just been increasing. We really haven't reached that point yet where we're limited to our resources to the point that we start leveling off. And then just think about how consistent the population was for hundreds and hundreds of years, and then what major changes happened in the 1800s that have really led to a skyrocketing. Well, there's all kinds of things, right? Think about advances in the medical community, advances in sanitation, understanding what germs were and how people were getting sick. All of those things kind of led to our population being able to survive and grow older and have more children, and then that population increasing as well. The problem is, though, our population's getting a little out of control. So a lot of people are encouraging population stabilization, and that's more or less when your birth rates and your death rates are about equal to each other. Because in the United States, at least prior to all of this, the birth rate in the U.S. was way higher than the death rate. So in 2019 and prior to that, our birth rate was about 2.5 times bigger. So we had about 2.5 times more people being born each day than dying. It is not equal population all throughout the world. There are places where population is relatively stable, and there's places where the population is booming. One of the biggest indicators of that is actually what kind of country you're talking about. So in developing countries, which is more of a PC term for what we used to call third world countries. So developing regions, places that are not terribly industrialized, they don't have medicinal birth control, they need children to help like go get water, for instance, if you looked up that stuff when we did the water pollution. All of those are big reasons why their population is booming in comparison to your more industrialized countries. So in case you were curious, by no means do you need to know these numbers. They're constantly changing. But the order of the most populous countries in the world really hasn't changed much in the past couple of decades. So number 1 is China. You probably already knew that. India is number 2. The United States is number 3, but look at that drop off. Like, we have less than a third of the people that India has. So yes, we're number 3, but we're not anywhere close to being contenders with 1 and 2. Indonesia may be surprising to you, especially because it's such a small country, which means its population density, how many people live per square mile, is insane. And then Brazil is number 5. So, like I said, country by country, it tells us a lot of information. So what you're going to be looking at today are population pyramids, and they're just graphs to show male versus female demographics and then age group demographics as well. So there's 3 major types of shapes that you'll see when you look at these pyramids. So the first one is rapid growth. There are lots of babies being born. So you'll see the bottom part of the graph where the babies are 0 to 4 is going to be drastically higher than the people actually making it to middle age. So in general, if it's like a triangle shape, then that is considered rapid growth. And like I mentioned earlier, we tend to see this more in developing countries. So those ones that aren't industrialized. Then we have stable growth, and that's where you really don't notice a drastic difference between middle-aged people and the young. Now, every graph on here is going to have smaller at the top age group, because that is when people are tending to not be around as much. But for stable growth, you're kind of looking at that bottom part. And if it in general is like a rectangle, then that's stable growth. This you find in developed countries, places that have good health care, that people are able to make it to middle age and older without having to be in war-torn countries or any of those things. Then we have declining growth, and that one is more of an upside down trapezoid where there's middle age is one size, and actually your number of babies being born is way smaller. This is also found in developed countries, where they're just not emphasizing the birth of children as much as the other things that they prioritize in life.